Welcome to our detailed guide on access modifiers in Java. In this video, we'll unlock the power of access modifiers and see how they shape the visibility and accessibility of your code. We'll start with an overview of the different access modifiers: public, private, protected, static, and final, each serving a unique role in managing your code structure. We'll dive into how the private modifier helps achieve information hiding by restricting access to class internals. Next, we'll explore the public modifier and its role in defining class interfaces, followed by the protected modifier and its impact on inheritance. We'll also cover package default, access, the static modifier for class-level attributes and methods, and the final modifier for creating constants and immutable classes. Ready to master access control and refine your Java code? Let's get started.
Access modifiers in Java are keywords that control the visibility of classes, methods, and variables, helping to implement information hiding and encapsulation. By using different access levels, such as private accessible only within the class, default accessible within the same patch, protected accessible within the package and by subclasses in other packages, and public accessible from any class, Java ensures that the internal details of a class are hidden and protected from unintended external modifications. This control over access helps maintain the integrity of a class and promotes secure and modular design. The private modifier in Java is crucial for achieving information hiding by restricting access to a class's internal variables and methods, ensuring they can only be accessed within the class itself. This allows developers to keep sensitive data, like passwords or account numbers, securely hidden from external access. Just as the saying goes, not everything needs to be public. Private fields shield important information, maintaining control over how data is accessed and modified, a principle that safeguards the integrity and security of a system. The public modifier in Java is used when you want to make class members accessible from any other class or package, but it's important to use it thoughtfully. When designing public interfaces, the key is to expose only what is necessary for external use while keeping the internal implementation details hidden. This promotes good encapsulation by allowing interaction with the class through well-defined, controlled methods without revealing how things work under the hood. By carefully designing public interfaces, you ensure that your class is both flexible for use and protected from unwanted interference. The protected modifier in Java plays a key role in enabling inheritance while preserving encapsulation. It allows subclasses to access parent class members, even if they are in different packages, while preventing access from other external classes. This makes protected useful when you want to share functionality between a class and its subclasses, allowing them to inherit and extend the behavior without exposing these members to the outside world. It strikes a balance between code reuse and controlled access, maintaining encapsulation while supporting inheritance. The default or package private access level in Java allows class members to be accessed only by other classes within the same package, making them invisible to classes in other packages. This access level is ideal for organizing code into packages, where related classes can interact freely while limit access from outside the package. It's a practical way to control access within different parts of the system, promoting a clear structure and encapsulation, especially when you want to share functionality within a package but avoid exposing it to unrelated external classes. The static modifier in Java allows class members, whether variables or methods, to belong to the class itself rather than to individual instances, meaning they can be accessed without creating an object. This makes it particularly useful for shared constants, utility methods, and managing common resources that need to be globally accessible. However, using static also comes with limitations. It can expose shared state between instances, which complicates information hiding and may lead to unintended side effects if multiple instances interact with the same static member. Thus, static enhances convenience, it requires careful management to avoid compromising encapsulation. The final modifier in Java is a powerful tool that prevents modification of classes, methods, or variables, ensuring they remain unchanged throughout the life cycle of the program. By declaring a class as final, you effectively prevent it from being subclassed, while marking methods as final stops them from being overridden, thus preserving their original behavior. This modifier is particularly useful for defining constants, as it ensures their values cannot be altered, and for protecting critical methods that should not be modified by subclasses, maintaining the integrity and stability of code. Overall, using final enhances reliability by enforcing immutability and safeguarding essential functionalities. As we conclude our deep dive into access modifiers, you now have a comprehensive understanding of how they shape visibility and control in Java. We began with an overview of access modifiers, discovering how each one influences the accessibility of classes, methods, and variables. We explored the private modifier, essential for achieving information hiding and protecting internal data. We then looked at the public modifier, which facilitates access and defines class interfaces. The protected modifier was examined in the context of inheritance, allowing controlled access across subclasses. We also covered package private access, the static modifier for class-level variables and methods, and the final modifier for constants and immutable references. With this knowledge, you're well equipped to use access modifiers effectively to enhance encapsulation, control access, and design robust systems. Keep these concepts in mind as you code, and may your use of access modifiers lead to clearer, more maintainable Java applications. Happy coding!